Hi everyone, welcome to my talk on testing a data science model. I appreciate this is an emerging area, therefore I found it quite useful to actually share my knowledge with you. I've actually done some research and asked some colleagues around the world who are in testing if they've actually been involved in testing a model or a data science model. And most of them came back saying that they're aware of this, but they've not actually been working in these teams. So I thought that's a great opportunity for us to actually get into. And in this session, my aim would be to actually give you an overview of what this is and try and inspire and guide you to see if you might end up liking this area and you could actually go and explore. So without further ado, let's get started. First of all, a little about myself. I've graduated with a BSc Honours in Computer Science. I fell into testing, I had no idea what testing was, and today I've got more than 7 years of experience and I find it really, really interesting to learn and to share. I've worked within various industries, as you can see, and some of my hobbies include dancing, yoga, teaching, and baking. Today's session would include information about what is a data science model and some background, the process around testing it, and some useful tips and complexities that I've come across and how those could be useful for you. Some stats. Currently, 80% of UK business are looking to hire a data scientist or seek data consultancy. IBM anticipates that data science will account for 28% of all digital jobs by 2020. This is great. This is a great opportunity for us to actually go in and validate those models and understand what they are. So, what is data science? In a nutshell, it's a collection of tools and algorithms to understand hidden patterns from raw data. It allows decisions and predictions to be made, and the aim of making informed decisions, basically. So, data science is more of a forward-looking approach. It works with real-world scenarios. It's an exploratory way with the focus on analyzing the past or current data. And it uses predictive analytics. Some teams might be using this, so it's a buzzword for you, predictive analytics. Organizations can find and look into patterns contained within data in order to detect risks and opportunities. What is a model? So let me give you a quick analogy. Imagine you're commuting to work in the morning. You sit into your car, you put your seatbelt on, and you start. So that is your driving experience. So that's the data side of things. You need data for the model. Then your brain would try different driving patterns to learn what works best. So if you are faced with traffic, you would find the best route to get out of the traffic. So that's the computing side of thing. And the model side of thing is an equation of data inputs affecting your target value. In this case, how long it takes for you to get to work. So if you got to work sooner, your model worked great. But if you got to work a bit late, your model needs training. Let me give you another example. Example is for a manufacturing firm. You can check what they sold last week and then check what if they use the same assumptions that were used then, what would be an acceptable sale for next week. This is basically sales data of a client to improve their production. So, data science modeling, what it does, it assesses the set of conditions and it guides you to make informed decisions. Now, remember, a model is a statistical black box. It's full of funky algorithms. And it uses probability distribution to understand the behavior of its inputs. It's more of a what-if model. So if a customer uses the parameter for the model suggested, then what their business could look like. It uses genetic algorithms as well. So genetic algorithms are algorithms that reflect the process of natural selection, where the fittest individuals are selected and inspired by Charles Darwin, actually. A model produces some indications that are being used as guidelines for your clients, and each model would use configurations or parameters per the client requirements. So what we do as testers, we actually test towards the expected outcomes and see if they are actually in line with what we need to provide or they're actually not. So we need to raise those as concerns. So the benefits of data science model is to help craft better decision making, identifying opportunities for businesses that they were not aware of, actions based on trends to help define goals, data-driven evidence, identification and refining of target results, so you're training your model, and mimics real-life scenarios. A model needs data, and the data, as you can see, is in 4 different styles. So structured data is it adheres to predefined data models. It's easy to aggregate data from various locations and databases, easy to store, access and process it, just like Excel files. Then you have unstructured data, which is not organized in a predefined manner. It's got irregularities in the data, therefore ambiguous as well. I use unstructured data, and it's important. What we have in our team is data schema, where the data engineer provides a data schema that we send to the clients, and we receive the data in terms of that data schema, which reduces any data biases. Then you have semi-structured data, which is self-describing data, uses tags and markers such as JSON and XML files. And lastly, you've got metadata, which, for example, could be photographs, and it provides additional information about a data set by telling you when it was taken and where it was taken. A basic kind of architecture here for you, and the scenario we will use is, imagine you are providing money on credit. Then the probability of customers making future credit payments on time is a matter of concern to you. So what you would do is you would push in the raw data from the clients. You would obviously have features on top of it that are doing what the client requires. You have your learning algorithm, which is the predictive analytics side of things. So just a little recap of what this was. It's a use of statistical and machine learning techniques to identify the likelihood of future outcomes based on historical data. Organizations use this to sift through current and historical data to detect trends and forecast events and conditions that should occur at a specific time. And then comes your model side of things with genetic algorithms. Now, genetic algorithms cause a bit of stochasticness, which means randomness. This randomness does not essentially have to be wrong, but if you have acceptable deviation set in your team as a process, then these could still go ahead. And then it provides you some future-like data if you're using predictive analytics in your team. So here you can build a model which can perform predictive analytics on the payment history of a customer to predict if the future payments will be on time or not. Now, before we start testing, it's important to not have the elephant in the room. Make sure all of you have the requirements and you understand the requirements in the same manner. You're all on the same boat. So have requirements gathering sessions, have planning sessions to brainstorm possible solutions, design and prototyping sessions, go and implement the model and actually test it at every stage. Don't leave testing till the end. And what you could do is, if you're in an agile team, you can use the 3 Amigos session to actually understand the problem the client is facing and how you can best provide a solution. Is the solution good enough for the client? Is it testable? Is it not testable? These are the kind of questions and ambiguities you can ask in these sessions. So let's get started. So a model can be of 2 types. It could be off the shelf or custom made. In my team, we've got a custom made model. Depending on what you use, you need to understand that you should have processes around testing for it. Also, you should consider how often you're going to train your model. So what I mean by training is you input data, you run it, and you observe the results and see if they're good or not. Also, as I've mentioned earlier, because of the use of genetic algorithms in the model, it would provide a bit of stochasticness, a randomness. So let me give you a small little analogy again. 5 plus 3 for me and you is 8. But for the model, 5 will go in as it is, and it will output as it is. 3 will go as it is and output as it is, but the result 8 would be 8.00001 or 8.00065. This, when you see it, you might think it's wrong, but if you've got thresholds in your team, so say, for example, you accept deviations between 3 and 5% of your actual results, then this is not essentially a wrong result. It's within your cap of threshold. So you can still go and accept it. So that's the type of stochasticness you might face for some type of data set that's running through the model. Some testing then. So verify the data set that you use for the model, have some understanding of what this data set is and what are we trying to provide. Validate the input versus output data results, understand the shape of your result, and make sure the values are of the right type and the data columns are matching where they should match and stochastic where they should be random. Test the areas you're certain about and uncertain about, so happy path and unhappy path testing, and those which cause some uncertainty in terms of results or due to the randomness. Make sure the results are within threshold, and make sure you get the thumbs up from the data scientists as well to understand that this is an acceptable result we can pass forward. Make sure the data pipeline works as expected, so no data is dropped or duplicates provided. And test using different parameters or configurations per your clients. So if you might have certain things that only accept strings, try and put some integers and see how it behaves. And lastly, explore the model, understand the model. Just go in without any agenda. Try and see if you find any underlying bug that you never knew about. So these are quite important things. Some more things that I've come across when testing data science models is new feature testing and regression testing. So when a new feature comes in, there's nothing to compare the model run to. Since it's a new implementation, you may find more issues around it. So try applying different configuration parameters and edge cases to understand the model outputs. If you do end up finding bugs as well, make sure they're not repeatable. Make sure they're solved once and for all. Work on a test plan with a data scientist and understand what is actually being implemented. Consult your results with a data scientist for more conciseness. The logic is tested in the unit tests. Run a model prior to a new feature and after. This is what I tend to do. So what you would see is something before would have less optimized results, and after you might have better results. Maybe the model took less time for a certain thing in your new implementation, and it gave you better results. And of course, exploratory testing. In terms of regression testing, what is regression testing? So you can confirm that a recent program or code change has not adversely affected existing features, and make sure bugs that were opened in the new feature are completely resolved. So what I tend to do here is I have a baseline run that I would potentially run in the previous release, and then I would create a new run and make sure they align. And if they are slightly bit different, that's okay, within the threshold of 3 to 5%. But if they're way too different, then you need to make sure you mention this to your team, and you can actually deep dive further with the data scientists and see what actually went wrong and if we can actually release or not. Remember, some models can have degree of randomness, so some areas would be expected to be random. Don't worry, deviation doesn't mean negative at all. If you have thresholds, it can still go ahead if accepted. No equation for the best answer exists, and rely on a good enough and fast enough answer. I know some of you may be thinking around automation. In this area, there's two things. If you do need human intervention, then I would not suggest automating this. But if you do have thresholds set, then you could potentially do some automation around that. So if the results are different to the prior release results, so if you have the threshold set, it would still potentially go ahead and you can automate that. But in terms of, for me and my team, my UI, I have a UI to run the model. So we can automate the front end side of things and run the model from the front end. So that's doable. Some useful questions and curiosities I had, so I thought might be useful to share with you. What is an acceptable test? Has a run completed and nothing broke within various stages of a model? Have we found anomalies? Did we drop some data? How do we know what we produced is the right result? How accurate are my results? What is an acceptable deviation? So all of these can be answered when you ask within your team. Therefore, be vocal. And other than that, what I would say is, how do I know I've produced the right results? So if you have a baseline run and you compare to it and you are kind of aligned, then that's good confidence. You've got great confidence there to actually go and provide those results forward, or you can be confident with those results. And in terms of deviation, if you've got thresholds in place and you've actually mentioned this to the data scientist that it's between a threshold, is it okay for me to pass this testing or not, then that's another thing. So stay in good communication with your data scientist and get the thumbs up from them as well. Let's practice this. So these are some locations and some birds in these locations. So what you need to understand is we are going to input this into the model and then see it in a dashboard if that's what you're using. So we're going to basically input the locations, which will be exactly same in the output, but the number of birds in each location may change. So this is just a visual example. I'm not going to do any technical check here. So the questions you should ask here is, how many birds were counted on the 7th site, for example, 7th site? What is the total number of birds counted across all sites? What is the average number of birds seen on a site? These are the kind of questions you would come up. And then would I expect an increase in site A1 or would I expect a decrease? This is now predicting things. So that's useful. And then at the end of it, when you finish your testing and running the model, you should understand, have I got a good understanding of what the model has provided? Have the predictive analytics and the genetic algorithms worked as expected? Does the shape of my data look good? What I mean by shape is not triangle, square, or circle. What I mean is a histogram or graph. Does it look good? Have I got any outliers? And if so, are those outliers acceptable or not? What I tend to use is the mean, the standard deviation, the absolute difference, the percentage difference to help me validate my results. Some complexities I've come across are around data. So if you've got less clients, the best option would be to have synthetic data set or a golden data set for some of you, as you may know it, and mimic your client data but respect the policies of the client data. Now, if we anonymize, make sure the file size is matched to the client's file size as well. So if you are anonymizing 50 characters, make sure you anonymize the 50 characters. What I did was I anonymized 50 characters down to 10. So some product description that was 50 characters, I wrote it down as description 1, 2, and 3. So that changes your file size. So try and stick to the exact file size your client has, because then you are reducing another potential bug of what the files or the data size that can be accepted into your model. Also, the model is quite complex. I don't expect you to know everything about the model, but have good understanding. That's vital. Knowledge silos. So some people may know a lot, some might not. So it's okay. Just try and be vocal. Make sure your questions are answered and make sure you document things as well. Dependencies. So there might be something that you might be building in the back end, but it may not have been mentioned to the front end developer. So make sure this is mentioned and you're not blocked. Your testing should be smooth end to end. So just make sure dependencies are captured, and this happens usually in the requirement side of things and the 3 Amigos session. Some tips for you to take away. So make sure you understand the data from a business point of view. Don't derail. I know that your model mimics real life scenarios and there's tons of assumptions. Assumptions limit scope, basically. You cannot pick all assumptions realistically because then you are derailing and what needs to be delivered won't be on time. So make sure you stick to your consumer requirements. Also, review and analyze a lot. So your specifications, you define your test scenarios, execute test scripts, review them, report and document if vital. I've been asked before if data science model testing can be done in agile, so in sprints. I've got 2 weekly sprints and it's possible, so definitely it can be done in sprints. Also, be ready for discrepancies. Just because a discrepancy sounds negative, it doesn't essentially mean negative. If you've got thresholds in place, that's all good. Some teams might need more precise results, so just reduce your threshold. Don't make it 3 to 5, make it less, 1 to 2, or just up to 1% deviation. Also, by providing these statistics and facts for employees and clients that they can access at any time, you are creating a smart and savvy team that can use these insights to drive more business. And once you have a process in your team, stick to it and try and look of ways to optimize it. We are not just optimizing the model here, we are optimizing the team as well in a way. Also, be present in all vital meetings. It's okay not to know everything. Pairing is useful. Raise your concerns wherever you find something that you don't understand. Make sure new features are being released often and bugs are not repeatable. And what does this leave me with? A hybrid tester, because I came in with testing knowledge and I've gained data science model validation knowledge. So we are hybrid testers here now. Okay, lastly, some useful tools for you to take away is SQL if you're using databases, some statistical knowledge. You don't have to be a pro. You can do most of it on Excel, by the way, the statistics, the basic ones. If you're using a front end to drive your model, then developer tools would be good to check your endpoints. And Miro dashboard if you're doing any 3 Amigos session. So, a little summary. Basically, aim to do some edge case testing and exploratory testing in your model. Make sure the model is providing accurate and precise results. And if you have thresholds, it's any deviation is within the threshold. Make sure the model can perform at a scale with new features. So make sure the model is maintainable as well, because if new features are coming in and your model is slowing down, there's something that's not happening right. Make sure it's still behaving as it is and it's not taking too long and no new implementation is impacting it negatively. So that was all from me. Thank you very much for attending my session. Please feel free to connect with me. I'd be happy to help you and share some more knowledge and learn from you.